students, I am Sharma, BE in Mechanical Engineering and faculty at askIITians since 2 years. Today we are going to discuss about gravitation, why planets moves around the sun, why moon moves around the earth, and we are also going to discuss about the concept of formation of tides, concept of formation of galaxies and evolution. We are also going to discuss about various phenomena observed on the earth and throughout the universe. I have divided this lecture into various parts. So in the first part we are going to discuss about the introduction of gravitation. Hello students, we are going to start gravitation. Let's get started. Now the topic we are going to cover in gravitation are what is gravitation. Here we will define the definition of gravitation. What are the basic examples of gravitation, and the next one, what are the laws under gravitation. So there are two laws we will explain here in universal law of gravitation. So next subtopic is measurement of gravitational constant G. Next topic is gravitational field, gravitational intensity, gravitational potential. Next one is gravitational potential energy, relationship between gravitational field and gravitational potential. Next is calculation of gravitational field and gravitational potential. Here we will calculate the gravitational field E and gravitational potential V at various points for various shapes. The next one is variation in acceleration due to gravity, Kepler's law, planets, satellites and weightlessness in a satellite, escape velocity, gravitational binding energy. The next one is inertial and gravitational mass. What are the difference between inertial and gravitational mass? We will discuss in this subtopic. Next one is concept building questions. We are going to arise some important question, general question. Generally people don't know the basic concept behind this basic questions. And the next one is conclusion. What is the advantage of learning gravitation? So next one, what is gravitation? Gravitation or gravity is a natural phenomenon by which all things with mass are brought towards one another, including stars, planets, galaxies and even light and subatomic particles. So gravity is a natural phenomenon which occurs only things with the mass. Without mass there is no gravitation, there is no existence of gravitation. So mass is the necessary for the gravitation, and it is applicable to stars, planets, galaxies and even light and subatomic particles. That means gravitation is applicable to every particle of the universe having mass. So there are some theories which explains the gravitation. The first one is general theory of relativity. General theory of relativity is explained by the Albert Einstein. According to general theory of relativity, gravity is most accurately described by general theory of relativity. So gravitation can be defined in two ways. The first one is accurately and the second one is approximately. So there are two laws in gravitation. First law explain the gravity most accurately. The law which explains gravity most accurately is known as general theory of relativity. So in the case of general theory of relativity, gravity is not a force. Gravity is not considered as force. gravity is considered as uneven distribution of mass per unit energy. Sometimes it is called a space-time continuum or a space-time distribution. So here this is the Earth and this is the curve, a space-time continuum. This is the curve. This is the curve of gravity, which explains according to the general theory of relativity. In case of general theory of relativity, there are 4 dimensions. We are considering here 4 dimensions. 3 dimensions are in space and single dimension, 4th dimension is in time. So here general theory of relativity is explained by Albert Einstein, and according to him the 3 coordinates are fulfilled by space and the other coordinates is fulfilled by time. So this is not in our syllabus. We are not going to focus here on general theory of relativity. So the next, however, for most of application, gravity is approximated by Newton's universal law of gravitation. So as I told you, general theory of relativity and Newton's universal law of gravitation, these are the 2 theories which explains the gravitation, but general theory of relativity explains the gravitation in accurate form. But for most of the applications, Newton's universal law of gravitation explains. So we are going to focus on Newton's universal law of gravitation. Gravitation is an infinite range force. All bodies with mass in the universe are drawn to each other no matter how far they are. Actually, gravitation is a force with attraction. It always attracts one body to the other body. So if there are 2 bodies, then first body attracts the second body and second body attracts the first body. So it is an attractive in nature. So, and the other thing is, it is an infinite range force. So the bodies with mass in the universe drawn to each other no matter how far they are. So there is no meaning of difference between 2 bodies. If there is 2 bodies in the universe having both mass, then there must be a force of attraction, force of gravitation between them. Now there are 4 fundamental interaction of nature. So generally in the whole physics, fundamental forces are divided into 4 parts. First one is gravitation, second one is electromagnetic, next is strong nuclear, and the 4th one is weak nuclear. So these are the 4 fundamental interaction of nature which defines all types of forces in physics. Now we are going to cover more about gravitation. So we are going to take more knowledge about gravitation. So gravitation is the weakest. There are, as I told you, there are 4 fundamental interaction of nature. So this is the gravitation is the weakest in all of these forces. So this is the important thing. Gravitation is the weakest force in all the fundamental interaction of the nature. So as a consequence, since the gravitation is the weakest force, so gravity has a negligible influence on the behavior of subatomic particle and plays no role in determining the internal properties of everyday matter. So gravity is the weakest force in fundamental interaction. Due to weakest force, gravity has a negligible influence, almost no influence on the behavior of subatomic particle. I will explain you later why it is. Now, gravity is the dominant force at the microscopic scale, that is cause of formation of shapes and trajectory orbit of the astronomical bodies including asteroids, comets, planets, stars, galaxies. So gravity plays a very important role in case of macroscopic bodies like asteroid, comets, planets, stars, galaxies. But a smaller particle like subatomic particles, there is no or negligible influence of the gravity, since force of attraction is directly proportional to mass of the body. So if the body is microscopic, so there is a smaller mass, so force is directly proportional to mass. So mass is smaller means force is smaller. So if mass is bigger, then force will be higher. So F is directly proportional to m. That's why gravity has dominant force in microscopic scale and negligible influence on a smaller particle like subatomic particles. Some practical example. Let us take some practical example of gravitation. Gravitation is responsible for causing the Earth and the other planet to orbit the Sun. Moon to orbit the Earth, formation of tide, natural convection by which fluid flow occurs under the influence of density gradient and gravity. So gravitation, due to gravitation, all the planets orbits to the Sun, Moon orbits to the Earth. Gravitation is also the cause of formation of tide, and it is also the cause of fluid flow by the convection, and it is also the cause of the formation of solar system, galaxy formation and evolution, and the various other phenomena observed on the Earth and throughout the universe. You can see here there are many types of galaxies: bed, spiral, irregular, spiral, peculiar, elliptical, lenticular. So there are many types of galaxies, and all these types, all these shapes depends upon the amount of force, amount of gravitational force acting between the particle, acting between the masses of the galaxies members or galaxies particles. Now this is here, this is the formation of tide, how tide forms. So this is the Sun, this is the Earth, and this is the Moon. So these are the three bodies having mass. There is a mass something, mass with the Earth, mass with the Sun, mass with the Moon. So all these three bodies having some masses. So if a body having mass, then there must be a force of attraction, force of gravity acting between these bodies. So when Sun, Earth and Moon come in linear position and Earth lies between Sun and Moon, then there is a force of attraction between Earth and Sun like this, and Earth and Moon like this. So if there is a seas this side on the Earth, then the formation of tides occur. I will explain in the next slide. Force of gravitation. Now I told you before, the smaller object, a smaller particle having a smaller amount of forces, and the macroscopic objects having higher amount or dominant of gravitation, because from here force is directly proportional to mass 1 directly proportional to mass 2 inversely proportional to distance between them. So if the bodies are smaller, if there are two bodies, then if there are two bodies and these two bodies are smaller in nature, smaller in size, then the force is always decreases. If mass is smaller, then force is also smaller. If mass will be higher, then force will also higher. So force of gravitation is dominant for the microscopic bodies and it is almost negligible for microscopic object. Here F is equal to G m1 m2 by r square. Here F is gravitational force acting between these two bodies. m1 is the mass 1, m2 is the mass of second body, r is the distance between the centers of this body, and G is the gravitational constant. The value of G is 6.7 into 10 to the power minus 11 Newton meter square per kg square. Here this is the mass 1, this is the mass 2, and this is the distance between these two bodies, and this is the force of attraction acting between these two bodies. And also gravitation is acting everywhere with mass. So in the cricket, if a ball is thrown or a projectile is thrown, so there is always a force of attraction towards the center of these two bodies. You have center of this ball and the center of the earth, so there is always force of attraction between these two bodies. Now question 1. Explanation of formation of tide. How tide actually forms. Formation of tides. So there are two types of tide. The first one is spring tide and the second one is neap tide. So the formation of tide is because of the gravitation. Mostly the main cause of formation of tide is gravitation. Now here is the sun. Now I am going to explain a spring tide. Here is the sun, this is the earth, this is the moon. Formation of tide occurs in 2 times in a month. Full moon and new moon. When sun, this is the sun, this is the earth. When moon revolve around the earth, then when move comes between the earth and sun, then here this is the force of attraction between the sun and earth, and this is the force of attraction between the earth and moon. So there are two forces. There are two forces acting on the earth which pulls the mass of the earth. So if the earth having water on this part of the earth, this region of the earth, then the water pulls and forms the tides. And the other case is, this is the high tide, and the other case is when moon is at full moon, then the force of attraction due to sun is like this and due to the moon is this. The mass of the moon is actually smaller, but it is effective in case of water surface. If this region contains water, then the force of attraction due to moon is more dominant here, so it also forms high tide. Now neap tide. So first quarter moon and third quarter moon. The neap tide forms in the first quarter moon and third quarter moon twice in a month. When sun and moon are at right angle. Here this is the sun, this is the earth, and this is the moon, or this is the moon. There are two positions. So this is the 90 degree, this is the 90 degree, or if you consider this is also 90 degree. So if sun and moon are at right angle to the earth, in this case, when there is a total gravitational pull on the earth, water is weakened. Because of it comes from two different directions, because there is a force of attraction between earth and sun is this way, and the earth and moon is this way. So the resultant of these two will be this way. Okay, so due to this moon, here is the position of high tide, or also here is the position of high tide, and due to sun, higher distance, this is the low tide, this is the low tide. Due to a smaller distance, this is a high tide. Since force of F is directly proportional to mass and inversely proportional to distance, square of distance. So here is there is a higher distance between sun and the earth, and the square of the distance is much more bigger. So due to this force will be weaker, and the force due to moon will be stronger. So this is the reason due to which tides forms. And here also we can explain, this is the earth, this is the moon. So this is the moon's gravitational pull due to gravitation. F is equal to G m1 m2 for earth by r square. And since earth is also rotating on its own axis, so if moon pulls this part of the earth, and due to this tides forms due to gravity, and since earth is also rotating on its own axis, so due to inertia this part also forms tide. So this is the explanation of formation of tide. Now question 2. The mass of earth is 5.97 into 10 to the power 24 kg, and the mass of moon is 7.35 into 10 to the power 22 kg, and the distance between them is 384,400 kilometer. Find the mutual gravitational force of attraction between them. Since gravitation is a infinite range force, so let us consider this is the earth and this is the moon, and there are also many other planets in this solar system. So they also apply the force between this planet and this earth, planet and moon. So there may be a significance, there may be a influence of these other planets on the force between the earth and moon. So here we are using what we have to find the mutual gravitation force of gravitational force of attraction between them. So we have to only consider the force between earth and the moon. We have to ignore all these other planets, force due to all these other planets. So we are going to consider only these two mass of earth, mass of moon, and the distance between them. So mass of earth is 5.97 into 10 to the power 24 kg. Mass of moon is 7.35 into 10 to the power 22 kg, and the distance, this is r, distance is denoted by r, 384,400 in kilometer. We will have to convert it into 384,400 into 10 to the power 3. We can't calculate in kilometer, we have to convert it in SI units, so meter. Now we can apply, we have to find force between these two bodies. So this is the force between earth and moon. This is the force of attraction between earth and moon. So from Newton's law of gravitation formula, F is equal to G m1 m2 by r square. We can put here the value of 6, G is 6.7 into 10 to the power minus 11. This is the value of G. Value of m1 is 5.97 into 10 to the power 24 into m2 7.35 into 10 to the power 22 by r square. So 384,400 into 10 to the power 3. We have to square this. So we can calculate this, find it, and this will be in Newton. Unit is Newton. Since this is the force, so this is the force, so the unit of the force is Newton. We are putting all these values in SI unit. This is the mass, so we are putting in kg. m1, m2 is also in kg, distance is also in meter, so the unit of force is Newton. So this is the force we have calculated. This is the force is acting between the earth and moon, and this is the mutual gravitational force of attraction between earth and moon. So that's all. We will continue gravitation in the next part of the video. Thank you. So students, we have discussed about introduction of gravitation, practical examples of gravitation, various parts of gravitation, and also we have discussed about the formation of gravitation. So in the next part we are going to discuss about universal law of gravitation. So stay tuned.